Alrighty, y'all. In this video, we're going to go over cost, revenue, and profit functions. So these functions are going to be pretty prevalent for the rest of the semester, so I want us to take a good bit of time and make sure we are comfortable with these functions. Alright, so a cost function. If you're running a business, a cost function is the cost of producing materials or a service. Okay, so for us, we're going to be looking at, for the most part, we're going to be looking at what's called a linear cost function. And so a linear cost function is basically going to take your variable costs and you're going to add to it your fixed costs. So what are variable costs? Variable costs are things that change or depend on how many units that you sell. So variable costs change from time period to time period. Fixed costs, on the other hand, have no relationship, or I should say they're completely independent of how many units you sell. So examples of fixed costs include employee salaries, the overhead for running a building, the lights, the electricity, that kind of stuff. Those are fixed costs because you still have to pay for your rent, you still have to pay for the lights in the building, you still have to pay for your employees, whether or not you make any units or not. So fixed costs are things like overhead. Variable costs typically are like your materials. All right, so your materials is based off of how much you want to buy, so that's why it's a variable cost. But as I said, for us, if you're asked to write a cost function, it's going to be a linear cost function, and it's going to be, it's going to be right here. C of x equals mx plus b. So as we know from previous videos, that's our slope-intercept form. Here, m represents the slope, so m times x gives you your variable cost. And b is your y-intercept, which represents your fixed cost, because a y-intercept is whenever x equals 0. And for us, that means that we're not selling any units. So the fixed cost represents how much you have to pay in costs when you sell 0 units. Also, throughout the semester, we're going to come across a price demand function. So a price demand function, which is denoted little p of x. Little p of x is denoted by, I'm going to have a typo here, is denoted by, like I said, little p of x, and the little p represents price. So when you're giving a price demand function, basically you're saying for a certain demand x, for a certain number of units I have to sell x, this is the price in which I should set. Okay, so that's the relationship with your price demand function. For a certain value of x, it tells you what your price should be. Our revenue function, okay, so basic business functions here is what I like to call these. Your revenue function is your quantity times your price. So for example, let's say that we're selling, we're selling iPhones. And let's say we're selling our used iPhones for $250 a piece. Let's say that we sell 4 of those iPhones. So what's our revenue from selling those iPhones? It would be 250 times 4, or $1,000. So anytime you want to find a revenue, what you do is you take the quantity at which you're selling and you multiply it by your price. Okay, so how does this tie into what we're going to be doing? Well, for the first set of homework problems here, or so I should say the first set of homework assignments, we're going to be given the price demand function. So we're going to be given little p of x. So that's our price. So to get a revenue function, what we need to do is multiply that price by the quantity. Well, for us, the quantity is going to be variable. It's going to change. So that's why we use the variable x to represent quantity. So to get your revenue function, what you do is you take x and you multiply it through to your price function. Okay? And then lastly, we have your profit function. That's where my typo came in. So the difference between revenues and profit is that your revenue does not account for the cost that you incurred when you sold that product. So your profit function will always be revenues minus cost, always in that order, revenues minus cost. All right, so for us, our profit function is big R of x minus C of x, revenues minus costs. Okay, I know that was a lot of definitions coming at you quick, fast, in a hurry, but hopefully that makes a little bit of sense. Now I want to get into 2 examples. Let's look at the first one. So the cost to produce a new model light bulb is $2.50 per bulb. The overhead cost before producing any light bulbs is $5,000. The demand equation, or the price demand equation for light bulbs is little p, price, is equal to 11.5 minus 0.003x. We're going to use this information to find the profit function for the light bulbs. And also we want to find the profit from selling 2,000 light bulbs. Okay, so a lot of information is coming at us fast. So let's recap. We said that our profit function, big P of x, is equal to our revenues, denoted by R of x, minus our cost function. Okay. Well, we've got some work to do. We do not know the revenue function. We do not know the cost function, but they give us the information we need in order to figure that stuff out. Okay. So, for example, here let's talk about the cost function. Let's start there. Remember, we said our cost function are variable costs plus fixed costs. Okay. Well, variable costs are dependent on how many units you sell. Well, they tell us that the light bulbs cost $2.50 per light bulb. Okay. That right there, that is our variable cost. Okay. The overhead cost is $5,000. So overhead costs represent fixed costs, right? Because I have to pay for the overhead even if I sell 0 units. So with that being said, that means that our cost function is it's $2.50 times each light bulb. Remember, the variable x represents our quantity, so it's 2.50x plus our fixed cost of $5,000. That's our cost function. Okay? Our revenue function. Remember, we said revenue is always going to be quantity times your price. Well, they give us a price function, right? That 11.5 minus a 0.003x. So what that indicates is that our revenue function, excuse my handwriting, is going to be the quantity, which is represented by the variable x, that represents how many light bulbs we're selling, times the price function, which is 11.5 minus 0.003x. Notice I put the price in parentheses because I need to distribute my x to that price function. So cleaning this up, our revenue function is 11.5x minus a 0.003x squared, where all I did was I distributed my x to both terms of my price function. Okay, we got our cost function, we got our revenue function. Now we are finally able to calculate the profit function. Profit function is revenues minus costs. So we take our revenue function of 11.5x minus 0.003x squared. That is our revenue function minus our cost function. And it's very important is that you need to put your cost function in parentheses because I need to distribute that negative. Okay, very important. So our cost function, as we found earlier, was 250x plus 5,000. Okay, I'm begging you guys, do not forget your parentheses. All right, so the next thing I'm going to do is I'm going to distribute that negative, and we're going to clean up this function a little bit by combining like terms. So 11.5x minus 0.003x squared, and I'm distributing my negative. It's a negative 2.50x minus 5,000. Distribute that negative. And then lastly, what I'm going to do is I'm going to combine like terms, and I'm going to go ahead and write my profit function in decreasing order of the power. What I mean is that I'm going to write the negative 0.003x squared first. We have 11.5x minus, let me highlight these. I'm next going to take the 11.5x minus 2.50x. So 11.5 minus 2.5 leaves us with a positive 9x. Then I'm just going to bring along the minus 5,000. So there we go, folks. That is our profit function. Okay. All right. The question also says, hey, find the profit from selling 2,000 light bulbs. So the profit from selling 2,000 light bulbs. Okay, we could do that. So that means all we need to do is plug in 2,000 for x, because x represents the number of light bulbs. So it's going to be a negative 0.003 times 2,000 squared plus 9 times 2,000 minus 5,000. Okay. Let's put that into our calculator. So I'm going to say, okay, got a calculator. Negative 0.3 times, it was 2,000, and we have to square the 2,000. Okay. Plus, I believe it was 9x, so it's going to be 9 times 2,000. Okay, so remember the parentheses indicates we're multiplying. And then minus 5,000. Okay, just let me double check. Yeah, looks good. All right, so if we go back to our calculator, hit enter, we get an answer of $1,000. All right. So our profit of selling 2,000 light bulbs is that we get a profit of $1,000. Okay. So that's kind of the generic, I guess, process you go through. You figure out your cost function, figure out your revenue function. You get your profit function by doing revenues minus costs. Please make sure you put your costs in parentheses. Clean up your profit function and then plug in an X value. Okay. Let's see here. Be careful. Maybe in your homework they ask you to find the revenue of selling 2,000 units. Let's do that really quickly before we go to the next example. What if we want to find the revenue of 2,000 units? Revenue of selling 2,000 units. Or 2,000 light bulbs. So what we do in this case is that we need to plug 2,000 into the revenue function. Okay? So we want to calculate R of 2,000. Well, what's R of 2,000? Remember, R is 11.5x minus the 0.003x squared. So it's going to be 11.5 times 2,000 minus the 0.003 times 2,000 squared. Let's get that number really quickly. Let's clean this out. 11.5 times 2,000 minus 0.003 times 2,000 squared. All right, and there we get $11,000. All right, so make sure you're careful in understanding what the question is asking for. Sometimes they ask for profit, sometimes they ask for revenue, sometimes they ask for cost. So make sure you understand which function you're working with. All right, let me get through this last question quickly. We have another, here we go. All right, so a company manufactures and sells jet skis. So the cost function is weird here. So this is not a linear cost function. So we have 4x plus the square root of 16x plus 2,000. Okay, where x is the number of jet skis produced. They want us to figure out what is the profit from producing and selling 121 jet skis if each jet ski is sold for $250. Okay. So we're going to proceed the same way as before. Let's talk about our cost function. Okay. Well, the cost function, it's already given to us. It's 4x plus the square root of 16x plus 2,000. So we don't have to construct the cost function. It's given to us. We also need a revenue function. Remember, revenue function is quantity times your price. Okay? Well, what's our quantity? It's the variable x. And then what is our price? So here our price is not variable. Our price doesn't change. It turns out that our price is a constant $250. So here our revenue function is going to be x times that constant 250, which just looks weird. So it turns out our revenue function is 250x because the order of multiplication doesn't matter. Okay, so here we have a constant price function. It doesn't change. All right, so now we have everything we need in order to calculate the profit function. Profit function, revenues minus costs. And put your costs in parentheses. So here we go. It's 250x minus our cost function in parentheses, which is 4x plus the square root of 16x plus 2,000. Okay. Just like before, I'm going to distribute my negative. So we got 250x. Distribute your negative. You get a negative 4x minus the square root of 16x minus 2,000. Okay, all I did was distribute my negative to all three terms. And then let's combine like terms. So our profit function will be, let's see, 250x minus 4x. That's 246x minus the square root of 16x minus 2,000. Okay. All right, they want to know the profit of selling 121 units. So that's 246 times 121 minus the square root of 16 times 121 minus 2,000. So let's see here. Let's put that into the calculator. So 246 times 121 minus, there we go, square root. So second x squared is how you get your square root. 16 times 121. All right, I need to get out of my square root. And then minus the 2,000. And there we go. We get a profit of 27,722. All right, so the profit of selling 121 jet skis is 27,722. All right, folks, I hope that kind of clears up a little bit how to get your cost, revenue, and profit functions. I'll see you guys in the next video.